You are at the ArcGIS Pro SDK for .NET technical session. We're discussing advanced Pro customization with a focus on categories and custom settings. Next to me is Uma Horano. I'm Wolf Kaiser. We are both on the Pro SDK team. You can find us on GeoNet. And Uma, I'm going to demonstrate a few things first in regards to custom settings, and then Uma is going to take us to multiple add-ins and then also categories, Pro categories. Quick overview, we're going to start out with the custom Pro project and application settings. Specifically, we're going to address user, application, and project settings. Then we integrate our project options into ArcGIS Pro. Then Uma is going to take over, going to talk about multiple add-ins, specifically in regards to versioning and dependencies. And then Uma is going to talk about Pro categories as well. So let's start out with the advanced customization settings. When add-ins or configurations need to persist settings and/or their state, there are three options. You can persist per user, you can persist on the application level, and you can persist in the ArcGIS Pro project file. So those are your three options that we're going to cover here. We start out with the application and user settings. The reason we start out with that is because application and user settings get added via the .NET application property settings. So it's something that's built in and wired into .NET and Visual Studio, and we use that functionality. In Visual Studio, you use the add-in project's properties and settings. You see a screenshot of that below. So you can right-click on the project properties and then select the Settings tab, and this is where you would add your settings. You can also use additional settings, file settings template if you need more than just one settings class. Visual Studio will then automatically generate a settings class for you. Settings are stored in a .settings file and the app config in the project. At runtime, they're dynamically stored in a users.config file in the users app data folder. So you don't need to worry about how that works. It's all handled by .NET out of box. And we're going to do a little sample shortly. So when you use the application and user settings, you would use the property designer to add your application properties. And when you enter these, you can first select the name itself that you want to give it. You give it the type, but then very important is the scope. You can have either user or application scope, and you can also give a default value as shown on this little screenshot here. Visual Studio then takes those settings from the property designer and creates a settings class with the same properties. All properties have a getter and setter in the code, just like a regular class. And then you can call a save method on the settings class to persist those settings. You see a little code snippet below. I have settings.default. I have a property that I defined called show when opened. It's a Boolean, it's set to false. And then I call the save method, which will cause that value, that property to be persisted. First demo, what we're going to do in this demo is we're going to create two custom settings, one user scope, one application scope, and then we'll see how we take it from here. So let me open up Visual Studio. And then to demonstrate this, I'm going to create a new add-in. So I'm going to use our project templates. I'm going to click on File, New Project. I drill down to our ArcGIS Pro item project templates. I select Module Add-in. I click OK. And our project template will stub out all the code that I need to get started. Now, because I want to add some code behind to show you some of the functionality. I'm going to add a item template in order to add just a very simple ArcGIS Pro button. So I drill down to my item templates. I select ArcGIS Pro. I'm going to call this settings test. I'm going to add this. And it will add the button to my add-in and then the code behind in which I'm going to put in my custom code. First, I have to define my setting, my custom setting properties. So let me do this by right-clicking on my project, going to the project's property page, and then I click on settings, and by default, there is no settings file, but I can click on this little link here. Project does not contain default settings. Click here to create a new one. I'm going to do this. And it created a settings file for me. So what I can do is now I can name my first setting. I'm going to call this my user. If I spell this properly, my user value. Well, there's a problem with this keyboard. There we go. It's a string. The scope is user. Now I'm going to say this is my default user value. So I can set a default value in here, which if I don't have any settings persisted yet, the default will be used. I'm going to do same for the app. I'm going to have an app value. I'm going to change the type here to a Boolean. I'm going to change the scope to application. I'm going to set the default to false. So I have two values now. I can save this. When I now build my project, Visual Studio will create the class that I need, the settings class, in the background for me. It should now be available. I'm going to go into my settings, which, needless to say, I misspelled. Excellent. It's the seedings class, the seedings test. So let me, in my on-click method of the seedings test, I'm going to first show what my custom setting values are, and then I'm going to make a change to it, and then I'm going to persist it. So let me first do a message box, and I'm going to show what my values are. So here's my user setting, and I'm going to use IntelliSense here. If I use properties, I automatically get to my settings, default, and then it's my user value. Here's the property that I added through that property designer. And then I'm going to do the same thing for my application value. Let me do this here. And then I'm going to say app setting. So the scope's slightly different. There we go. Since I'm the only user on this machine, I don't think it would make a difference for me. But now I'm going to make an update to this. So I'm going to take this my user value, and whatever this value was, I'm going to override it, and I'm going to say this was changed. And now I have to persist it so I can quickly call the save method, and this will persist that value for me. So let me run this real quick, and we'll try it out. Now, in order to test this, I have to run it twice, right? First, I'm going to change that value. I persist it, then I run it again, make sure it's really there when I pick it up again. So here's my Pro coming up. Excellent. I just open any kind of project, doesn't matter which one. My seedings test is under the add-in tab. So when I click this now, I can set a breakpoint in the code, but I don't think I need a breakpoint. So you can see that a message box pops up. It tells you my user setting is my default user value. That's what I put into my property sheet. And once we exit the onClick method, it should be to change to this was changed. So let's click OK here. Here is my application value, which is false. And now the value should have been changed because I called the save method to persist it. So let me close this instance of Pro. I'm going to reopen. I'm going to just start the debugger again. And since this is a user setting, it doesn't matter which project I open up, I should get the proper value. So I think, let me just open up another one. I'm going to open up this project here. So again, I click on my seedings test, and you can see the value has been changed from my previous run, and it was persisted, and when I ran the application again, I got my changed value. So this is simple custom settings, both for user and application scope. And now, let's go back to the slides. So now we're going to go to project settings. So project settings are stored as key value pairs in your project. Keys must be unique strings, and values must also be strings. That's where you store your values associated with a certain key in. Project settings are added to the module settings writer when the project is saved by overriding on write settings async. As you know from previous sessions, our central hub for add-ins is always a module. So we would do this in the modules class, where we override the on-write settings async method. And here, as a parameter, you get passed in the module settings writer. And in order to add your own settings to this, is you just add key value pairs to the module settings writer. So here I add, in this little code snippet below, my settings 1, so this is my unique key. And then I add a value to this, and again, this has to be a string. So if you don't want to store a string, you will have to serialize your data, your state, as a string, and then deserialize when you read it back. We'll see that in the code a little later. Again, so these settings will go into your project. So when you choose a name for this, then you should choose a name that's somewhat unique to your application or to your add-in, maybe preceded by your company name or organization name. Because if somebody opens your project file and they read the settings, then maybe accidentally you overwrote their settings. So settings 1 and settings 2 was not a very good example, because I noticed that I opened some existing project files and I would get values there which I knew nothing about. So make sure you name it uniquely. Settings are retrieved from module settings reader by overriding on read settings async. On read settings async is called when the project is opened, but only if you have settings. So you are responsible for your own default values in case of a project that has no custom settings. So below you see a little implementation and a little pattern. The pattern actually uses a has settings boolean to indicate whether your project, when it was opened, had any settings. So what we do is, again, we override the onRead settings async method of the module. We get passed in our module settings reader, and to retrieve values, we can use the key settings 1 and settings 2 to retrieve the values. If we have values, if onRead settings async gets called, needless to say, we have to indicate that to our module, and we set has settings to true. Now, the read settings async gets always called before the project is opened. So if I subscribe to the project open event in my module, that event will occur after I read my settings. So I can use the has settings status to see if I have to initialize my settings to default values. So if I didn't have any settings loaded, then in this case, I initialize my defaults by hand. And when the project is closed, I set my has settings back to false. So that's a little pattern that you can use. Needless to say, there's other ways to do it. So let's now do a little demo, and we take a look at this. Now, I know I closed my team viewer before, but it came back. As a matter of fact, let me close it again. There we go. So here's a little project that I prepared. In this project, I have a class called Project Changes. This class actually has some behaviors which allow me to track any changes to my project. So for example, if I add a map, if I add a layout, the Project Changes class will collect this information for me. There's two things in this Project Changes class we're going to take a look at that I need to persist. One thing is whether or not I should track changes, which is a simple flag. And the second one is all the data that I collected in Project Changes, all the changes to the project. I store an instance, I create a new instance in my module class. Now, needless to say, when I add this class, I create a new instance of this class in my project, there's going to be no state, no data within the Project Changes class. So I will have to use on the onRead settings to see if I before persisted any project changes with my project, and if so, I use the module settings reader to retrieve by keyword, in this case it's change list, and I retrieve any changes that were saved and persisted earlier, and then restore the state of my project changes from that string. So this is always a string, as we know. So I have to restore the state from a string. I use JSON as a string, and then deserialize the JSON string into my class properties. I'll do the same for a second property, which is track changes. Track changes is just a simple Boolean, and it's true or false, and allows me to turn the tracking of changes on or off. And this is very easy. I just have a bool property, and I set that depending on what the string is. Finally, when I save the project, I now have to persist the state of my project changes object. And what I do is I use the save to JSON to save all the data was collected in change list. And then finally, I save the flag true or false, depending on what the state of that flag was. Finally, here a little behavior. This is one of the behaviors of my project changes class. I set a breakpoint here, so when we debug, we can see this. This is where my project changes class actually collects any additional changes to my project. So we'll see that we have a breakpoint there, and then we can observe this. So let's run. In order to see what my project changes class contains, there's a little doc pane that allows me to change the project change flag from true to false with a checkbox. And I have a list view that shows me all the changes. So let me rebuild this, and I'm going to run it. And then we'll take a look of what happens behind the scenes. Okay, Pro starts up. Now, if I open a project that I used earlier, there will be values that I already persisted earlier. So I could actually, there we go. Initialization code, we'll step over this. So for me to start from scratch, you can see, let me just show you how this works. If you look at your project change tracker, this is the little dock pane I told you about earlier. Let me move this to the left here. Well, didn't quite want to move. So you can see previously there was data persisted. We restored that data. So if I make any changes, let me view my catalog. I'm going to move this to the right side so we can see a little bit better. I moved both, great. So let me say, for example, I'm going to add a new map. So I'm going to add a new map to this. So you can see it now hit my breakpoint on projects items changed. And you can see I create a new entry in my list of items, of change items. And when we take a look at our user interface, you can see at 5:51, I added a new map. I can delete something real quick, and then we can see that. And then I don't think we have to do any more. So let me delete this layout here. Again, it was hit. I'm going to undo this breakpoint now. Let's continue. And then if I look at my project change tracker, you can see I removed this layout. So this is the information that I want to persist now. So let's go ahead and I'm going to save this project. And you can see the on-write settings async that we overrode earlier. We hit a breakpoint in there. The module settings writer was passed in. And now we can use project changes where we have a save to JSON function. So if I want to take a look at that real quick, it should be a string. So if I go to the immediate window and I'll take a look what this looks like. So you can see save to JSON returns JSON string that serializes the attributes, the change list events of my project changes instance. And we simply add this to the module settings writer, giving it the keyword change list. So let's continue. So now this is persisted with our project. So if we want to get this list back, what I would have to do is I have to open another project. I can do this right from here. I'm going to open my project 13, which appears to have no settings. And then if I open my feature test again, you can see I now stopped at my on-read settings async function that I overrode. The module settings reader is being passed in. We said we have our little pattern here where we have has settings set to true, as we saw on the slides earlier. We now have settings. So here's I retrieve the change list settings value, and I do get that very same string that I passed in earlier when I saved the project in the on-write settings async. So what I have to do now, I have to take that string and then restore the project change state from JSON. So I do that in the load from JSON method. And then finally, I'm going to look at my track changes state, which is my true false. And then depending on the string that I have in here, I restore the Boolean track changes value. And then I can continue, and we'll take a look. And now you see it opens the project on my left. And you can see the same layout, which was the last change to my project that I tracked, was done on 5/51. And so we completely restored the persisted state of project changes from earlier. Okay, so these were project changes and how you would persist these within a project. Key value pairs and strings. So now let's look at the project options. So we want to integrate our options into ArcGIS Pro. ArcGIS Pro has a menu, options screen that comes up, the dialog that you see a screenshot below. And we want to add our project and application options to the Pro Options property sheet. So to provide a property page for both project and application options, you use a Pro SDK property sheet item template. I'll show you that in a second. Then in the Config.daml, you make a few changes. In essence, you update the property sheet with a ref ID Esri core options property sheet. So as you know from our earlier sessions, you can modify within the Config.daml any kind of existing ArcGIS Pro user interface element by just referring to its unique ID. So the unique ID for our options property sheet is the Esri core options property sheet value you see right here on the slide. And now, once you do this, you can insert your own project and application options in there so you seamless integrate. So to add project and application property pages, you use the template. So you say add new item, ArcGIS Pro property sheet. This will add an individual property page, both the view and the view model. Since this is all MVVM, you will need to add both, the view and the view model. But the item template will do that for you. So this adds a custom property sheet container, which is declared in the config.daml. We'll take a look at that shortly. And then adds a button to show those custom property sheet containers. For our purposes, we only need the page, the view and the view models. So we really don't need all the other buttons and property sheets that are created. We just need the pages, the view and the view models. The rest of the generated content can be deleted or ignored. So you see a little screenshot below. This is how you would add the ArcGIS Pro property sheet to your system. So a little bit detail about property pages. The page view is implemented using standard WPF. It's a user control. The page view model derives from ArcGIS Pro Desktop Framework Contracts page, and you must implement a commit async override for your save logic. Commit async is called when the user clicks OK on the property sheet, and is only called if your page is dirty. So there is a isModified true-false property that you have to set to true for the system to recognize that somebody made a change on your specific sheet. Now remember, there's a whole bunch of tabs on that property sheet where user can make changes. Only when isModified is set to true, then the commit async function is called. So you want to set the isModified true whenever a property value is changed. So this marks the page as dirty. Down here is a little pattern that you can use. We'll see that a little bit later in code. So if your property has changed, then we set the isModified to true. And then again, commit async will be called. So you can override both initialize async and uninitialize as needed. So this is where you can initialize your value from maybe whatever value persisted in application settings or user settings. And it's executed when the page is loaded and destroyed respectively. So here's a little bit coding by PowerPoint. And what we do is we're going to go through the extra content that resulted from our template generation. So we used the item template to edit a property sheet. And you can see we got extra buttons. So here's the extra button we got. And then we got a bunch of property sheets, insert property sheet. And then here's the actual page. That's the piece we actually want to keep, and the content of the page. So these are the two things we want to keep down here, if you see where my mouse cursor is. So let's see what we do is we delete everything we don't need. And then we use a update sheet. We want to update the Esri core options property sheet. And we take the pages that was generated earlier with copy and paste it in here. And we also change the tag from page to insert tag, because update property sheet is a little stickler. Insert page and page is usually synonymous, but in this case, it wants us to specify insert page. So we specify insert page, and then finally, we have to pay attention to the group tag. The group tag by default is set to group 1, group 2, one of these values. We have to specify that we either want to be under the project group or under the application group. So here's the second one. You can see, again, it's used group 1, but we override this and say group application. So this property page on the top would appear under the project section, and the page down here would appear under the application section. All right, let's take a quick look on how that works. So earlier I ran this sample and inserted my property pages. You can see I have a bunch of buttons to show these property sheets. I'm going to delete these buttons. I don't need them. Also down here, I pasted already the code snippet that I need instead of my insert sheet. So I'm going to paste this here. I want to update the Esri core options property sheet. Here we go. And I'm going to just take the page content and move it into my update section. Okay, the second page. So I have one page for projects and one page for application settings. So needless to say, I'm going to override this. I'm going to say project, and I'm going to say application. Okay, and I can delete the insert sheet down here. I don't need it. So that's left over from, now you can see we have a little underline here. So this is where I have to change my tag to insert page. And then needless to say, I need to make the same changes for the closing tags and for my second property sheet. So this is all I need to do in order to get this running. Now let's look at the code behind real quick. I have the project options. This is what I generate, just the checkbox application options, what I checked here. And then for the commit async and the set property where I update the is modified flag, I have some breakpoints. So when we run this, probably would have been a good idea to rebuild this first. So let me rebuild. And build, rebuild. And then run it. So now we should be able to go to our backstage, and we should see our options in the backstage. So this is just a better integration. I could have had my options on a custom screen somewhere, but I want to integrate into ArcGIS Pro so it looks seamless. So you can see here, I have under the project group, I have my project tracking option. So this is the screen that you saw earlier. This is my property sheet, just has a single checkbox. And then if I scroll down under the Pro title change, I have my second property option, which is show when opened. So when I check this, you can see the property has been updated. My set property has been called. My property is being changed. I step over it, and now I can see the is modified is set to true, meaning my page is dirty now. So when I now click on the OK button, I can make more changes now. Finally, when I click on the OK button to accept all changes, this is when my commit async is being called. This is where I actually then take my value. So here's my value that I changed. I save it, I persist it. This happens to be an application option. And now that option is being stored. So if I reopen that project, that I can see whatever options I changed will appear again on the backplane under the options, integrated with ArcGIS Pro seamlessly. And that takes me back to the slides. And we'll switch to Uma.
I'm going to start with some multi-add-in deployment scenarios. Here are two scenarios. We deploy multiple versions of the same add-in on a system, or we augment an existing add-in with additional capabilities. So here on this slide, I have some information on the add-in versioning scheme. The version of an add-in is set in its config.daml. You update the version attribute in the add-in info tag in the config.daml. Here on the snippet at the top, notice the highlighted version attribute. And Pro will always load the latest version of an add-in regardless of its location. So even if you have multiple well-known folders with different versions of the same add-in, Pro will always load the latest add-in. Here at the bottom, I have a screenshot which explains the order of precedence while loading add-ins based on its version. We use a 4-decimal semantic versioning scheme, major.minor.patch.build number. So a build number, a field is trumped by a higher build number. The patch trumps the build number, and the minor version trumps the patch number, and the major version trumps the minor version. Here is another scenario. In some cases, you will need to deploy functionality incrementally across multiple add-ins. So in some cases, you would first deploy some basic functionality in a core add-in. So for example, here in the screenshot at the top, notice the Acme tab. It contains a couple of core functionality buttons. So these, this tab and the button are deployed by a core or a basic add-in. And then notice the screenshot at the bottom. Notice that there are 3 optional feature buttons. These are also installed into the Acme tab, but they're installed by a new enhanced add-in. So how did we accomplish this? Here are the steps. First, we use the DAML to update the core add-in. So here in the snippet at the top, you include this snippet in your new add-in. Set the update module element. Set its ref ID attribute to the module ID of your core add-in. And then use the update tab child element. Set its ref ID to the ID of your Acme tab. And then you use the insert group element, and this is where you provide the ID of your new group with the new functionality. So from my screenshot, this is the ID of the group that hosts the optional buttons. And then we want Pro to load your core add-in first, and then it needs to load your new add-in with the optional features. So there is an add-in dependency over here. So you control this add-in dependency by using the dependencies element. You can see that in the screenshot at the bottom. And here we have the dependency child element, and its name attribute is set to the GUID of our core add-in. Okay, let's move on now to categories. categories are a mechanism for logically grouping together components that provide the same functionality. So internally, Pro uses many categories. So I'm going to use Pro's usage of categories to explain this concept further. So for add-in development, custom categories provides an extensibility mechanism that provides functionality beyond what you would get with DAML. So I'm going to explain that using two scenarios. I'm going to explain custom categories using two scenarios. So Pro SDK has a variety of categories for its internal use, and the Pro SDK uses some of these categories. So one such example is the construction tool item template. So when you create a custom construction tool, it gets dynamically added to the point, line, or polygon palette of your create features pane. So notice here on the screenshot, I have an icon inside the red box. These are custom construction tools, and they have been added to the corresponding palette in the create features pane. So we're going to see how it does that. So here in this screenshot, this is the snippet over here is the tool definition of a construction tool, and this is in your config.daml. Notice that the category ref ID here is set to Esri editing construction point category. So this category is a predefined Pro category. So setting this category for this tool allows this tool to be displayed in your point palette of your create features pane. So you can see that in the screenshot at the bottom. The icon within the red box is my custom tool, and it's available in the point palette. Similarly, this is the DAML definition of a polygon tool. Here you can notice that the category ref ID is set to Esri editing construction polygon, and this allows this tool to be displayed in my polygon palette. Okay, so now let's create some custom categories. I'm going to demonstrate this by using two scenarios. In scenario one, I'm going to use categories to group my items into an ArcGIS Pro gallery element. And in scenario two, I'm going to enhance a base add-in with extra functionality from additional add-ins. So here is scenario one. I'm going to extend or configure a gallery to host a collection of buttons and tools. An important thing I want to mention here is that you cannot extend a Pro gallery using DAML. For example, there is no such pattern such as an update gallery insert button. So we are going to use categories to identify which buttons and tools will be hosted on our gallery. So let's walk through the steps for this scenario. The first step, we define a new category. So we define a new category in DAML, and you can see that in this code snippet. In the DAML, within the categories element, I create the insert category child element and set its ID attribute to my custom gallery. In this case, I'm calling it the Acme Custom Gallery Tools. So step two, I identify some category requirements. We call this the contract. These are our custom requirements. For this particular scenario, you can see my contract requirements are listed here. First, my category components must be a button or a tool. They need to implement plugin wrapper. Next, each of these buttons or tools needs to provide a version information, and optionally, they can belong to a group. Now let's move to step 3. I have to register my buttons and tools with my new category, and I do that in my config.daml. I use the category ref ID attribute on my button or my DAML or button or tool DAML declaration. And then I add my content child element with the version attribute and the optional group attribute. Now let's step through the code snippet to see how this is done. So what you see here is a button definition inside the controls group in the config.daml. So first, I set the category ref ID attribute, and I set its value to my new custom gallery. This is the Acme Custom Gallery Tools. Next, I use the content child element and I set a version attribute and a group attribute. The version is required and the group is optional. So this is this pattern of adding the category ref ID attribute and including the content information to the button element is repeated for each button or tool that we want to register with our gallery or category. So now we have defined a new category. We have designed our category requirements, and we have registered our category components. The final step 4 is implemented in code. We have to read and load our category components. This is done when we initialize our gallery. So first, we verify our contract requirements. Is each component a plugin? And then we check if these components have a version attribute and if they optionally belong in a group. And if these contract requirements are met, we add our components to our gallery. So first, here are some of the Pro API methods that can be used while you work with categories. First, here is the get component elements method available in the categories class. You pass in the string, which is your category ID, and this returns an enumeration of component elements. And in this case, our component elements will be a button or a tool element. And then you use the get content method on each of the components, and this returns the content element that we defined in the config.daml. So let's step through this code, the code snippet. So first, we get a collection of our component elements. We use the categories.getComponentElements method. We pass in our category name, which is Acme Custom Gallery Tools. This returns us a collection of component elements, in this case, our buttons. And here's the full code snippet. Here on line 4, notice how we're using the get content element. This returns the content element defined in DAML. We get the version and the group attributes. And the important line here is line 10. We test our contract requirement. Each of our components needs to implement the I plugin wrapper. And if it does implement that, then we add it to our gallery using the add method. Okay, now let's look at this in the demo. So here I have an add-in project, and I've already added a gallery item template and a collection of buttons. So here, step 1 in the config.daml, I have defined my new category. Notice the categories group. I've included the insert category child element and set the ID attribute to my new gallery, new category, Acme Custom Analysis Tools category. So this defines a new category in DAML. Next, here are all my controls, my buttons. I've added 6 button elements to this add-in project. And for the purpose of this demo, these buttons just demonstrate categories, but in reality, you could use buttons for custom workflows. So notice that each of these buttons have a content element. This is part of our contract requirements. The content information, version information, and group information are set here within the content element. So now in my particular gallery, I want to register buttons 1, 2, 3, and 6 to my custom category. So notice here on button 1, I have set the category ref ID to my new category, which is Acme Custom Analysis Tools. And I've repeated this for button 1, button 2, button 3, and button 6. Okay. So now I've defined my categories, my new category. I have created my contract requirements and have registered 4 buttons to this new category. So next, in my gallery class file, I load my components, my category components. So here in the constructor, I have my initialize method. And within the initialize method, I load my category components. So I'm using the get component elements method, and I'm passing in my category ID. In this case, Acme Custom Analysis Tools. So now let's build this and step through this code. Okay, now I'm going to start the debugger. ArcGIS Pro loads. And it's going to open a very simple project. So here is my new tab, my Configure Gallery tab. When I click this, my method in the gallery constructor will be hit, my breakpoint. And I'm going to step into this method. So first, I load my gallery components, my category components, get component elements. Now let's step into this loop. So now over here, it retrieves, I'm iterating through the first component retrieved. So when I use IntelliSense and hover over the first component, notice that this is button command 1. So this is my first button number 1 that has been registered within this category. Here I'm using the get content method to retrieve the content element defined in DAML. So here I get the required version attribute and the optional group attribute. So next, I test if this component retrieved is a plugin, and if it is a plugin, I add it to my gallery. And of course, we repeat this for each of the components registered within this category. So now if I hover over the next component retrieved, notice that it is command 2. So now let's run this. I'm going to disable my breakpoints, and then I'm going to run this add-in, and let's look at the result in Pro. So here is my gallery, appears on the Pros ribbon, and when you expand it, you can see buttons 1, 2, 3, and 6 are hosted in this gallery. The rest of the buttons that are included in my add-in appear directly on the Pro ribbon. Okay, now back to our slides. Now to my scenario 2, which I call the custom reports. In this scenario, I'm going to enhance a base add-in with extra functionality from additional add-ins. So let's say that we first release a standard or default add-in. This add-in creates a default report style. And then users in our organization, they can get additional report styles by installing new add-ins. We do not want to recompile the base add-in each time our users need a new report style. So how do we accomplish this? This is scenario number 2. So here in the screenshot, notice this window over here. Notice that this drop-down has a basic report style. So this framework and the report style have been provided by our default add-in, which is in add-in number 1. So then the users install the add-in number 2, and they get an extra report style. So we're going to see that in this scenario. So let's walk through the steps for this scenario. Step 1, we define a new category. So we do that in DAML. Within the categories group, insert category child element, and we set the ID attribute to Acme Custom Reports. This is the new category that I'm defining. Step 2, I document my category contract. These are my custom requirements, and I'm going to need my report providers, which are my components, to implement the iCustom interface. So here in this screenshot, you can see a sample of my iCustom report interface. It's very simple, has a collection of a few properties and a method. Okay, step 3, I implement my report providers. So these report providers can be in external modules, meaning they can be different add-ins. They need a standard .NET class which implements my iCustom report interface. So this is my contract requirement to implement my report providers. And then, of course, I register each of these components in my config.daml. So here's a code snippet on registering and creating the report providers. Here within the categories group, I've included the update category ref ID attribute is set to my new category, which is Acme custom reports. So this informs the Pro framework that I will be registering a component within this category. So here I'm using the insert component element, setting the ID attribute, and the important attribute is a class name attribute. It is set to default report. So the default report needs to implement the iCustom interface. And of course, we have the content child element with the version, name, and other optional properties. Okay, so now step 4, implemented in code, we load our category components. So we do this in the base add-in, in the initial default add-in. So we use again the get component elements method, and we pass in the name of our category, in this case Acme custom reports, and then we test for a contract requirement. So for each of the components retrieved, we check if they implement the iCustom report interface. We instantiate each component using the create component method, and we cast it as the iCustom report. We're going to see that in the code snippet coming up. So here in this code snippet, here first we load our components. We use the get component elements method, pass in our category name, Acme custom reports, and we load our components, and we're going to iterate through each one of them. Here is the full snippet. We use the get content method and get our content element just like before, and then we get all the attributes of the content element such as version. And then here on line 6, I'm using the create component method on the component retrieved to instantiate the component, and then I cast it as the iCustom report. So if this passes, this particular component gets added as a report to my collection of reports, and this allows me to visualize it in Pro. So I'm going to show that in this demo. So first, in this folder, I have two add-ins, my default report add-in and my extra report add-in. So first, I'm going to install this add-in. And then I'm going to open up Pro, a very simple project. So here on my Reports tab, I'm going to open my Reports window. So this button and this Reports window, these were all created by my add-in that I just installed. And the default Reports add-in that I just installed has also given me a basic report style that you can see in this drop-down. Okay, so now I'm going to close the Pro application, and then I'm going to install a new add-in, my extra report add-in. Now, when I relaunch Pro, on the Reports tab, I'm going to bring up my Reports window again. So now notice in this drop-down, I have an extra report style that has magically appeared. So this was accomplished using categories. So I was able to install a new add-in, my extra report add-in, and it enhanced the basic functionality created by my default report add-ins. So let's look at that in Visual Studio. So here is a Visual Studio project. Here I have two projects, my default report projects and my extra report projects. But in reality, these two could be in two different solutions, but for the purpose of this demo, I put it together. These both create add-ins. So now let's look at the default reports. This is my base add-in. So this is the config.daml of my base add-in. And here within the categories element, I've defined my new category, insert category, ID is set to Acme Custom Reports. So this is where I define my new category. And then next, here is my iCustom report interface. Just like the slides, it's a very simple interface, implements a few strings and a method. And here is my .NET class file, my default reports class file. And as you can see, it implements my iCustom report. So this is my default report provider. And then back in the config.daml, this is where I register the default report provider. So within the insert category, notice my component element. The important thing I want to point out here is the class name attribute. It is set to my default report class. This is the class that I just showed you. This implements custom report interface. And of course, I set the content element within this. Okay, so next, here is my extra report add-in. So within this add-in, here is my extra report report provider. This is a .NET class, and again, it implements the same iCustom report interface. And then within the extra reports config.daml, I register the extra report provider. So within the categories element, I use the update category. I set the ref ID to my custom category. In this case, Acme Custom Reports. And this is where I insert the new component for my extra report. I set the class name to the extra report class file that I just showed you, and its content elements. Okay, so now what you see here is the module class file of my base add-in. This is a module class file from my default reports, and this is where I load my components. So I do that in the module classes initialize method. I load my components, and within this method, I use the get components method and pass in my category, my Acme Custom Reports category, and then I iterate through the components retrieved. So let's run through the code for that. Okay, so now I'm going to start the debugger to load Pro. Okay, so now within my Acme reports, I'm going to display my report window. So the module base classes load component method is called. I'm going to step into this method, and here I load my components using the get component elements method. And inside the loop, this is the first component retrieved. So in IntelliSense, you can see that this is the default report component. So now here I use the get content method to retrieve the content element. I get its version attributes. And this is where I instantiate my report provider. I cast it as an iCustom report. So now if that passes, then I add it to my report collection so that I can view it in Pro. And I repeat this for all the report providers registered on my machine. In this case, I have the extra report. So if I hover over this, you can see that this second component retrieved is extra report. So now I'm going to disable my breakpoints so that you can see the result in Pro. And here is my report window with the two report providers available in this dropdown. So that's actually the end of this session, and hope Wolf and I were able to provide you with some good information on some advanced customization options with the Pro SDK. Thank you.
Thank you.